For question number 11, we need to calculate the energy difference between the first and second energy levels for an electron in a 1 angstrom box. Then we need to calculate the wavelength of a photon with this energy. So to approach the first question, we can just use the equation E n2 minus E n1 equals n2 squared minus n1 squared times Planck's constant squared over 8 times the mass times the length of the box squared. So we have all the information we need to calculate the energy difference. So N2 is just 2, so 2 squared minus 1 squared multiplied by Planck's constant. Planck's constant is 6.63 times 10 to the negative 34 joules times second squared over 8 times the mass of an electron. This is an important constant to remember. So an electron is 9.1 times 10 to the negative 31 kilograms. Then the length of the box is given in angstroms. So 1 angstrom is equal to 10 to the negative 10 meters. This one is an important constant also to remember. So we have then 10 to the negative 10 meters squared. So using our calculator, we will get an answer of 1.8 times 10 to the negative 17 joules. Now let's just check to make sure we can get joules. So we have joules, which equals kilogram times meters squared over second squared. So if we square that, we'll get kilograms squared times meters to the 4 over seconds to the 4 times seconds squared, because don't forget that seconds in Planck's constant, seconds squared over kilogram times meter squared. So seconds, we're left with seconds squared. Meters, we're left with meters squared. And then kilograms, we're left with just 1 kilogram. So we're left with kilograms times meters squared over seconds squared. So that equals 1 joule. So the units are also correct. So that's why at the end we get 1.8 times 10 to the negative 17 joules. Now let's move on to the second part of the question. So the energy we just calculated, let's rewrite that. It is 1.8 times 10 to the negative 17 joules. Now, how do we calculate the wavelength of a photon with this energy? So we need to remember the equation energy equals Planck's constant times frequency. And then remember that using the speed of light equation, we can say that Planck's constant times the speed of light over wavelength also equals the energy. So we have all the information we need to calculate the wavelength. So let's reorganize that last equation. So we'll get that the wavelength equals Planck's constant times the speed of light over the energy. So wavelength equals Planck's constant 6.63 times 10 to the negative 34 joules per second times 3 times 10 to the 8th meters per second over 1.8 times 10 to the negative 17 joules. So you will find out that the joules will cross out, the seconds will cross out, and so we're left with meters. And we'll get 11 times 10 to the negative 9 meters, approximately. And that is nanometers. So we can also say it will be about 11 nanometers. So 11 nanometers is just an interesting fact, is around the X-ray region.